Hello, and we're going to talk about conic section. A conic section is a curve obtained as the intersection of the surface of a cone with a plane. There are a few types of conic sections such as parabola, ellipse, hyperbola, and circle. First, we got the circle. It is a set of points in a plane that are equidistant from one point. It contains a center and radius. Examples include blocks, pizza, and Ferris wheel.
Morning to everyone. Today I'm going to discuss about chapter 4, Conics. And I'm also going to explain a little about the uses of circles in daily life. So as you can see, there's a question here. It's basically about a cell phone tower like Digi Tower, Maxis Tower, designed service with 12km radius. So basically there's a tower here and it only services for 12km radius, as you guys can see. And it's also stated the tower is located at coordinate 3, 5. Okay, so let's just say this is 3 and 5. By units and km, so the coordinates are km. That's just don't care about that. So they're asking what's the standard equation of the outer boundary of region service tower, and is a cell phone user at 80 in the service range. So they're basically asking if a person stands at 80 coordinate, will he reach the tower now? Will he like get signals for his phone, like to use internet, YouTube and stuff? Okay, so to do this, first we just have a rough sketch of a plane. This is the origin. We plot 3, -5 is right here and here, so it's here. So here's the tower, okay, tower, and they're asking 80. 80 is basically lying on the x-axis, so 8 is here. This is the user. So they're asking from here to here, is it 12 kilometers or 12 units to be said in a plain language? So is it 12? So to find out that, we can use the formula D. But before we go on, we have to find the extended equation for this one. So what we do is just x plus 3 squared plus y, we got 5 here, so it's like minus 5 equals to this at 12 kilometers, so we have to square it, it's 12 squared. So it's like x plus 3 squared plus y minus 5 equals to 144. It's a simple match here, okay. So we have to find the distance between the point tower and you. So to do that, you just have to use the formula of general formula, very simple ones from Form 5. So you got plus and y2 minus y1 and square it, okay. Square it and just fill up, like very simple, filling up. So what you do is 8, since the point is like here, 8 minus 3, okay. Here note this, it's very important. Now y is around 0 here, minus 5, as you know the tower is at 5, okay, 5 squared. When you do this, you're going to get around, when you use the calculator, you're going to get 146 units, also known as km here, okay, in this question. So when you see here, 146, set of 146 equals to 12.08 approximately, but the question only says it only can get service with a kilometer of 12km radius. Okay, so as you can see, this is not equivalent to 12km radius. Thus, the user wouldn't be able to use the internet. So this is how this one of the example of daily life application using circles. It's just a very simple circle like radius. This is a radius, so they just use this method. That's it. Thank you.
Next is parabola. Parabola is a set of points in a plane that are the same distance from a given point and given line in that plane. It is include focus, directrix, vertex, and axis of symmetry. The examples are including a satellite, bridges, and projected motion in games like Angry Birds.
What's up guys, today we're gonna talk about the conics. I let this student before, he said about the circles. Now it's my turn to talk about the parabola. Basically, parabola is connected to build a bridge. So, I have a question to explain to you guys, and I already illustrated the bridge arch to make it simple for you guys to understand. Let's go. Here to here is a 30 meter on the equation, and here to here is a 10 meter. So we go here, okay, here. So this is standard form. We simplify it, we get this. We got this, and we substitute the value that given in the equation. We just calculate, and we got y equal to 1.6, which is equal to OF. So DE equal to CF equal to CO minus OF here. So if you want to find the DE, you must minus CO minus OF 10, because this one, the question asks me to find the height of the arch 6 meter from the center on either sides. So basically we want to find this one, and we got 1.6. So we want to find this one in the final answer, and 10 minus 1.6, we got 8.4. So peace. Thank you guys.
Last but not least is ellipse. Ellipse is a set of points in a plane such that the sum of the distance from two fixed points in the plane stays constant. It is contained foci, center, major axis, and minor axis. Examples include football field, pool table, and the solar system.
Okay, today we're gonna talk about ellipse. There is a lot of use of ellipse in our daily life, such as people who are trying to make a rugby ball for their brands. This is the general equation for ellipse: x minus h square over b squared plus y minus k squared over a squared equal to 1. Okay, this is the general equation. For more understanding, we are going to test one question. The question is, sketch the ellipse of a 9x squared plus y squared equal to 9. So as we can see from the general equation, this side must be 1. So to get 1, we will divide all of this with 9. So when we divide off this, we will get this: x squared over 1 plus y squared minus over 9 equal to 1. So there is no h and k in this equation. So it means that the h and k is 0. The h and k is the position of the center. Okay, from this equation, we will get that if a squared equal to 9, a will get 3, b squared equal to 1, of course b will be 1 also. So when we get this, we can also get the f, the focal length. The formula is c squared over a squared minus b squared, and I already get the c is 2 square root of 2. So this is the diagram for the rugby ball that we just talked about. Okay, from this is the center C. From this to this is B. B equal to 1 from that we get before. This is 1, so of course there will be negative 1. This is the position, negative 1. Okay, from center to the V1, we will use A. Also from the equation that we get before, so V2 also equal to A. The the f we get from this equation, 2 square root of 2. F2 also use the same equation. Okay, after all of this, we just need to put all the coordinate. So C equal to 0, 0, vector 1, V1 is to 0, 3, V2 to 0, negative 3, V3 1, 0, V4 negative 1, 0, and F1 0, 2 square root of 2, F2 0, negative 2 square root of 2. Okay, that's all.